So, I mean, it's pretty awesome being a young founder because you don't see the downsides of things. You don't see the risk. You sort of just like go, go, go. And growing up, I spent a lot of time in like workshops and things with my dad, who used to and still does to an extent, like buy crashed and like old aircraft and actually restores them into flying again. There's just always some sort of like underlying desire to go and do something big. The dream for me, like my dream job, was always a Formula One engineer. I was basically like, why don't we build race cars from Harakeke? Happened in the late towards the end of the 20th century. The world just got obsessed with plastic, and everything was made from it. It was just like, just every company that you'd want to work with ever was there. And we bought a snowboard along, and it got stolen on the last day. Somebody, when we were packing up, somebody went and nicked it. Once you start to tie in the rich history and the cultural history around it, then you can build a product which can really fly, almost literally.
This is Pavlyukovskyy, and welcome to the TechMates podcast, where my partner Hendrik and I explore how Kiwi and Aussie founders are reshaping the future and what sets them apart. Hendrik and I have been part of successful companies in Silicon Valley and Europe, and now bring that expertise to partner with entrepreneurs in Australasia. By sharing the personal stories of successful Kiwi and Aussie founders and how they got here, we hope to inspire you to dream big. This is TechMates, bringing an outsider's perspective to the stories of those daring to disrupt down under. Let's dive in.
Cool. Well, welcome to the podcast, Ben.
Thank you. Thank you. It's good to be here.
Thanks for joining us. Yeah, we'd love to kind of deep dive into your background, your history, and you're obviously the CEO of KiwiFibre. So I'd also love to learn more about that and how you ended up founding KiwiFibre. But maybe to get started, would love to learn more about how you grew up. You're from New Zealand, obviously. So would love to learn more about kind of your childhood and your journey towards university.
Yeah. No, awesome. Yeah, I mean, my childhood wasn't too long ago, I guess. I'm my 25th birthday is coming up in about a month. So yeah, it's pretty awesome being a young founder because you just don't see the downsides. You don't
So
see
you were born
the
in 2000?
I'm a 2000s baby. Yeah.
Oh my God.
Wow.
Yeah. So I mean, it's pretty awesome being a young founder because you don't see the downsides of things. You don't see the risk. You sort of just like go, go, go. And people, normally people see the risk and opportunity and actually weigh that up. Whereas for my co-founder and I, it's just like, who cares? Let's just try it. Let's just try this thing. But essentially, like, most things can be traced back to childhood and growing up and stuff. And I grew up, and so did my co-founder Will, actually, in a sort of rural environment. So I grew up just outside of Auckland, so New Zealand's biggest city. Grew up about an hour south into the country. Lived in a few different places, so like got used to change, got used to different houses, got used to different groups of friends, got used to doing different things, different sports teams, that sort of thing. My dad's an engineer, mum's a teacher, so I guess ended up with a few of those soft skills and a few of those harder skills as well, even though I didn't turn into a very good engineer, but that's further in this story. But that's probably why I ended up doing this. But growing up, I spent a lot of time in like workshops and things with my dad, who used to and still does to an extent, like buy crashed and like old aircraft and actually restores them into flying again. And that's what my grandfather did as well. So I definitely grew up in an environment of like, something very creative, something very bit different, I guess. And there was definitely a process there of like, okay, we've got this aircraft that needs new wings, and we've managed to salvage the fuselage and got a new engine out of this. And it was always a process that I was exposed to, of taking stock of what is there and then going and building on that. And I guess similar things have been emulated, although in a very different context with what we're doing now. So lots of change growing up, lots of creativity, and free reign to just go and like just do things as a kid. And because we grew up quite rural, it was a good hour to go and see my mates like socially. And so you'd have to plan logistics of like, okay, dad finishes work at this time, mum finishes work at this time. your dad can pick me up, my mum can drop you off, sort of things. So as a kid, it was always logistics, like an hour travel here, half an hour travel here. I know that.
Why was that? Why wasn't the case? Did you live just why'd you live so far from everything?
I don't know. It's just I ended up going to rural schools, and my parents liked living in the country, away from, the noise and the just having a bit of space. It was just the lifestyle we ended up with. And then like dad wanted a big shed to go and build stuff in. So like fair enough, you get that in the country. So it was just a very different lifestyle.
Yeah. Sounds like your dad and your grandpa were kind of risk takers as well, right? It doesn't sound like the easiest job in the world to kind of rebuild old aircrafts.
Yeah, well, it's funny because yeah, risk taking and the fact that you're going and rebuilding old aircraft, but then at the same time, like the decision making criteria that like my dad follows, for instance, and he's actually in the workshop now, which is quite funny. And he's come to visit the office and the workshop for the first time today and yesterday. But like the process that he goes through as an engineer in decision making, whether that's in decision making for personal like things or in a professional setting or from an engineering sense, in order of like doing calculations on a member as part of this aircraft part. It's all so regimented, and so a lot of my analysis of decisions is kind of stems from that way of thinking, but then it's also blended with the screw it, let's just go and make a decision kind of thing that you have to have as a founder. And I think that's why that's kind of definitely become my style of making decisions. It's like very, very analytical. Let's go this because of this. But then at the same time, if we've decided that, we're going with it and we're not looking back.
And do you know how to fly?
Physically, kind of.
Do you have a license?
Actually, no, not really. I'll
Okay.
learn one day, but don't have much time or money for that.
Right. Cool. And then you went on to study engineering, right?
Yeah, so weighing up university choices and or what I was going to do after school, I was like, well, what am I interested in? Cars, planes, building things, designing things. I'm going to go study engineering. That's the logical choice. That's what, my family have done. It's just what's obvious. So moved from Auckland to Canterbury University, which is quite a good engineering school there, to go study mechanical engineering. I did a couple of like bridging papers because I didn't do the required maths course at high school. And I ended up spending about 2 years trying to do the first year of university for engineering. And that was tough. It was much less of like actual design engineering and much more maths than I anticipated. And so just straight up didn't enjoy it. I wasn't solving the problems, the hands-on actual real problems that I thought I would be. So I ended up transferring towards the end of my second year, transferred to industrial design and commerce, which was quite an interesting new degree at Canterbury because it's basically very similar in concept to the process of building a startup and solving a problem and making a product. It was very centered around this is the like go and explore a problem, go and hang out with the problem, go and speak to people who have the problem, and then come up with design sketches because it's all very tangible product focused. Being industrial design, it was like go and come up with concept sketches as to how this person that you've identified could solve this problem with this product, and then look at manufacturing methods and techniques and looking at materials, and test the product on the person who had the problem. Does it solve it? Yes. Okay. How do you put that into market, into production? If not, straight back to the drawing board kind of thing. So that was the degree that I ended up doing. Blended with commerce, which was ending up being quite handy in a sense of change management and all that kind of thing.
Interesting. And did your dad and grandpa, I mean, I don't know how influential they were in your life, but did they feel kind of like you should have done more hardcore engineering?
Not really, because I was learning about things like CNC machining, 3D printing, all these like relatively high tech kind of, or compared to the craftsmanship style that they were used to. Like, I brought home something that was 3D printed and showed my dad, and he was just like, wow, this is incredible. And only 5 years later, he's finally got himself a 3D printer. Yeah, they kind of understood what it was all about after I sort of explained the process which we go through. And it was things like CAD, so computer aided design, and using things like SolidWorks and Fusion 360 to create things, which was just like totally replaced the last century kind of ways of doing engineering that they were used to.
Did you, when you were growing up with them, I mean, did you get a sense, did they kind of teach you some of those skills and kind of teach you a mindset of like how they went about repairing airplanes and was that
Yeah.
kind of like different than what you learned in school? Or was that, or did that supplement what you learned in school?
Yeah, it was definitely a very practical approach that like most engineers within mechanical engineering and civil engineering that were my peers, they had no practical skills. Like they had never stepped foot in a workshop before the university workshops. They couldn't use hand tools, they couldn't use power tools. You gave them a broken machine or a engine and they had no idea what they were doing with it. Whereas I knew my way around all of that a lot more. And that became super relevant, like especially with what we're doing now, because we need to be able to do something, build something, fix something on the fly. And yeah, it would have become apparent later in the conversation, like why all of that is so important in trying to make machines work with other machines. But there's certainly a level of practicality that I gained from that upbringing, which was super handy through studies.
I'm surprised that your peers didn't have that same level of like, I guess, familiarity with the tools, given that it's New Zealand. I feel like a lot of folks in New Zealand grow up pretty, a lot of them grew up on a farm or they're just in nature quite a lot. Pretty practical folks, right? I don't know. At least that's what I
In
found.
general, yeah. Yeah. Most of those types definitely don't go into university as well though. There's an
Mm,
increasingly amount of school leavers going into trades and, specialist qualifications after that rather than university.
right.
University numbers spiked so much after COVID. There was just like so many people just going into university because it was like, what else do you do? But
Mm.
yeah, there was certainly skills that I had that my peers didn't have.
Did you ever consider not going to university?
Not really, because I just didn't really know what else was out there. There was really the careers people at school, at high school, I remember, were just so useless. They were basically like, if you're smart, you go to university. If you're dumb, you don't. And it's like, is that it? Like, what else is there?
What did you, I mean, what advice? I mean, I guess you could have maybe gone down the path that your dad and grandpa did, right? Did you consider that?
Sure. Yeah, I could have done sort of some mechanic trade or something, but I didn't. I kind of wanted to do something more than that. I never really knew what I wanted to do, but I knew it was big. I knew
Hmm.
that there was some sort of big purpose or big thing that I wanted to do, but I've only recently figured out that what that is.
And where did that come from? That, you kind of feeling or knowing that you want to do something big.
I really don't know. There was just always some sort of like underlying desire to go and do something big, I'm a bit of a perfectionist by nature, which is a bit of it's a good thing for business and it's a good thing for, going and achieving something because it means you've got a hunger and desire to do it. But then at the same time, nothing is perfect, especially when you're running a team, you can't expect perfection. But because I'm a perfectionist, I want the best outcome of anything. And if I'm going to go and have a career, I want it to be huge.
Well, yeah, it's interesting. It's interesting. Do you find that a lot of your peers had a similar mindset, or were you different in that way?
There definitely wasn't that level of ambition amongst my peers when I was at university. I started doing what became KiwiFibre at university and going through some of
Right.
the like startup programs and things there and explaining the concepts of, investment or explaining the concept of like, okay, I'm going to go build a business. Like that just wasn't even on the cards for anybody at university. There was just not that exposure to it, similarly to how there was just no exposure for anything else rather than going to university or being a builder. When I was at high school, those were the only options. There was no exposure to anything else. But just the same way as there was no exposure to what startups were properly at university.
Yeah, that's why I'm like, because I'm thinking, I think part of the reason why we wanted to do this podcast is to sort of help inspire, other folks from around the country in both New Zealand and Australia to sort of see that there's, folks just like them, folks
Yeah.
like you who go out and do something and create something that didn't exist before. And I'm just curious, kind of, yeah, where. where that drive came from. Was it kind of seeing examples of that? Was it reading books? Was it maybe listening to podcasts, seeing videos? I don't know if you had any kind of like thoughts about what actually got you curious and excited about doing something kind of on a big scale. Because I think, you know,
Yeah.
like New Zealanders, they have this, well, I know Australians as well, they have this like tall poppy thing, right? Where like just kind of do the thing that everyone else does, don't really stand out too much. So it's pretty impressive, I think, whenever you can, and it's like a small country kind of on the edge of the world. And so to think that
Mm.
like from here, you can actually go and create something world changing, you got to have some like thing there.
Yeah. Yeah. You've got to have something there in terms of just the raw ambition to do it. And you've also got to, and this will be a theme later on when we start talking more about the business as well, but there needs to be something really unique about what you're doing if you're coming from New Zealand and doing it, because otherwise someone else in the world can blow it away with scale or proximity or speed. There's got to be something uniquely New Zealand that you're leveraging.
Yeah, yeah, I guess we get to that in a moment. I'm curious, like,
Yeah.
what came first for you? Like, did you come across the idea and then realize you could kind of build a company out of that, or was there kind of a drive within you to build something, build a company, and then you came up with the idea? What was the process like?
Yeah, well, I guess coming back to sort of Mark's question of why, like, where that sort of ambition and drive to do something came from, like the dream for me, like my dream job was always a Formula One engineer. That was like the coolest thing. I was like, I get to travel, I get to work on cool cars, get to be around all the, glitz and glamour of it, whilst also being an engineer. But that was always the dream. And I thought, hey, I could get into that through the industrial design thing. I could get into material science. I could get into some specialist aspect of that instead of being a general mechanical engineer. So I'd always, Formula One, I was always watching that. One thing that caught my eye in the 2021 season was seeing Lando Norris's seat in his McLaren made from natural fibers. And I was like, oh, okay, that's interesting. Because at the same time, through my material science paper as part of my degree, we were learning about composite materials and fiberglass, carbon fiber, Kevlar. And around that time, I sort of put two and two together and saw, okay, we've got these materials that normally Formula One cars are made from. Why are natural fibers, particularly flax linen, the linen same as linen in your shirt, why is that being used in a race car? Oh, that's cool. Not knowing any idea about the business, not knowing any idea about the potential strength and things. But I asked my lecturer, whose name was Dr. Huber, I said, what's this all about? And turned out that he's one of the world's leading natural fiber composite engineers. And he was just happened to be my lecturer. He's German, and now he's at the university in Luxembourg. But he turned out to be one of the world's leading natural composite engineers. So we're talking about it, and then in the next assignment, which Will, who's now my co-founder, and I were group partners in, he said, right, you're going to, for this assignment, you're going to take on a waste material and you're going to turn it into something. You're going to turn it into a product and essentially save this material from having to go into landfill. And that material was what New Zealanders know as cabbage tree leaves. And it's nothing to do with cabbages, but it's like this particular leaf off a tropical tree which dies and then falls to the ground and just gets caught in lawnmowers. And it's too strong for the machinery at the dump to break it up and put it through the composting system. So it just has to go into landfill. And so we were given these leaves, and that was when I was like, well, these leaves are tough. What if we could make Formula One cars out of it? And so tried to look at some research about
The natural question.
yes, the natural question was, what's the deal with this natural strength? And so we tried to find some research on these cabbage tree leaf fibers, and there was like nothing out there. But that led us to stumble across, firstly, a whole lot of curiosity, and secondly, what New Zealand's fiber industry used to look like, and how natural fibers were, in particular the Harakeke fiber, was New Zealand's first industry, and thought, well, it was crazy. Looked at some of the data and material engineering properties of comparing fiberglass and carbon fiber and the linen fiber that was used in the Formula One car and Harakeke. And I was basically like, why don't we build race cars from Harakeke? And fast forward,
Right.
that was 2021. So fast forward 3 and a bit years, and now we've done it. We've built race cars from
Yeah,
Harakeke.
amazing. And we'll get into that. So I guess I came new to Australia and New Zealand only a few months ago. I had no idea what Harakeke is. So maybe can you tell us a bit more about what that is? Because I think it only exists in New Zealand, right?
Yeah, so Harakeke is commonly referred to as the New Zealand flax, although it's biologically not a flax and it's in a completely different family. But it's one of the most common plants in New Zealand, and it grows everywhere, especially along waterways, along lakes, rivers, streams, on unproductive land, riparian zones, and areas of land that you can't farm on. And it's a very, very common plant, and it's of significant importance to the Māori people in New Zealand, so the indigenous people of New Zealand. And they've been using it for centuries for making sails for boats, for tools, for bags, all this kind of thing. It produces not just fiber, but seed, oil, root extract, gels, and green matter with antiseptic properties. So some of these other extracts you can use in skincare, or the possibilities for it are endless. Yeah, when Europeans came to New Zealand in the early 1800s, they quickly saw what Māori people were doing with this fiber, and they quickly industrialized it, and it was one of the first like trading items between Māori and Pākehā. It was one of the first trading items because it was one of the strongest things in the world at the time. It made the strongest rope in the world. You could sail from New Zealand to England on one set of Harakeke ropes or like 3 sets of linen flax ropes.
Wow.
And
And was that the material that was the cabbage tree that you were referring to earlier?
So the cabbage tree leaf is another type of fiber that was just harder to work with, and I don't know, maybe one day we'll turn that into a product. But we had a few shreds of prior commerciality and sense of possible scalability there with the Harakeke, where there was nothing with the cabbage tree.
And so what was that? What happened to that project, the project university?
So we parked the cabbage tree leaves after the project and quickly pivoted to Harakeke Fiber instead. We went and visited the last remaining Harakeke mill because there used to be one in every town in the country that produced fiber, and they all burnt down because they were incredibly dangerous. But there's one left that was left, and it's near Will's house out in the country near Invercargill at the very bottom of the South Island. So we went and visited him, and he told us about the history, and it was just like, this is so cool. There was such a story to be told here. Let's turn this into some fabric and make some race cars.
So the project at university did you guys end up making a race out of the cabbage tree?
No, we ended up turning the cabbage tree leaf. We managed to turn the cabbage tree leaf into a small amount of textile that was like the size of a piece of paper. And that was a very basic textile that basically proved, hey, it's possible, but we're going to stop that project there and start using Harakeke fiber instead. It's longer, it's tougher, it's easier to handle slightly than cabbage tree leaf. So then we ended up entering a couple of the Entree projects, the Entree competition at the University of Canterbury, which is like an entrepreneurship course thing that they put you through and teach you how to pitch. And then we did the University of Canterbury Centre for Entrepreneurship summer startup program, where we won a scholarship to spend all summer full-time on the business. So we ended up doing that with the loose idea of turning Harakeke into race cars. At the time, it was like, let's turn it into some skis or a skateboard or something. But we had no idea at that time what the size of the prize or the industry or the strategy or how to scale it or anything like that. We had no idea, but that was kind of a blessing in disguise because we would have been put off if we knew how much work it was.
So you start off as a random project at universities, like turn these cabbage leaves into something useful. You make it into a textile. And then what you realize actually there is a lot better material in the form of Harakeke that we can actually turn into material like a composite material.
Yeah, we discovered there was a history behind Harakeke, and so there was knowledge to build off and knowledge to put together to build something from.
Got it. That's cool. That's cool. So what happened? Why did that industry go away?
So it was the biggest industry in the country. It was New Zealand's biggest export. The first patent in New Zealand was filed for a machine to extract the fiber. This super rich history, and for decades, towards the end of the 1800s, it was the biggest industry. The strongest rope in the world. It was really sought after stuff. 36,000 tons was exported in 1916, and there was a peak in exports for every war around the world because it was used in the marine industry. In the 80s, it basically stopped after World War II, because that was the early 50s, late 40s was around the when plastics and polyester in the form of ropes was made available, and because the Harakeke industry basically had all of its eggs in one basket with rope. As soon as a competitor came in that was like just cheaper, it was cents in the dollar compared to Harakeke. The whole Harakeke industry died pretty much overnight.
I see. So plastic-based products were cheaper than Harakeke.
Yep, yep, yep.
Was Harakeke stronger? Is it a more, is it more strength as a material than like plastic?
Well, plastic was just like you'd go through more. Plastic wouldn't last as long, but because it's way cheaper, you get the same use for less price, even though you're using more and more ropes or whatever you're using. You can just replace it cheap, and the environmental factor wasn't even a thing back then. And nor were the world just got obsessed with plastic, and that was definitely a big thing that happened in the late towards the end of the 20th century. The world just got obsessed with plastic, and everything was made from it.
Got it. So you knew that history, then what made you think, okay, maybe it's time to bring this back, given that it's like, why did you think that was possible?
So step one was the idea that we could turn Harakeke into a usable product to replace carbon fiber and fiberglass. We had no idea why. We had no idea. We had no idea apart from that idea. But then we needed to find out, like, okay, what's the point in all of this? Like, what problem could we actually solve? And so if we just started developing a product just because we thought it would be cool, that we wouldn't have gone anywhere, because we didn't understand the problem at that point. We didn't understand who had a problem, why anyone would want it. We just thought it would be cool for a project, just for us. But that was enough for us to keep going. So around that same time, William and I went and talked to composite manufacturers around New Zealand. So we went and talked to the likes of SailGP and tried to talk to Rocket Lab. They didn't want to talk to us, but now they are. We went and talked to boat builders, ski manufacturers, camper van builders, anybody and everybody who was working with fiberglass and carbon fiber, who could just tell us what it's like to see the factories. Like, we were just trying to get a job, like a summer job at the time, because we just wanted to work in an industry that was turning making cool things from composites, race cars, boats, or something like that. So we were just trying to get a job. But through those conversations, we discovered a massive problem, and it was the fact that, like, firstly, you walk into a fiberglass factory and it's just full with like these tiny fiberglass fibers in the air, just getting into your throat, into your eyes. It was just like, it was awful. The place stinks of toxins. It's just like, okay, I don't want to work here anymore. But there's a problem. I'm curious, what is going on here? So there was the human health problem. That was the first one that struck us. The second one was the amount of waste that was being produced. There's so many single-use materials and plastics in the industry. The resins are all just petrochemical based. Carbon fiber is literally just oil in fabric form. Like, it was like this. If this is bad for my health, this has got to be bad for the environment. And then the third thing was like, okay, we asked the technicians and engineers in these companies, what is carbon fiber and fiberglass actually like to work with? Like, what is the boat that you build? What does that end up like compared to using wood or compared to using another material? And one of the boat builders said that carbon fiber boats were like, it was like being inside a metal drum with a chimpanzee banging on the outside of it, because the reverberation, because of just how stiff and how and how vibration transferring carbon fiber is just reverberates all that sound. And so it was like, oh, what if you could dampen that with a material that could really absorb that energy? And it just twigged, and it was like, that's something a natural fiber can do. What if we built a natural fiber replacement for this that stopped that sound reverberation problem? And then we talked to a ski and snowboard manufacturer, and he said, yeah, the vibration transfer in snowboards on icy New Zealand slopes is really annoying. So he's having to use a rubbery resin to work in with the carbon fiber to absorb that energy. It was like, why are you using carbon fiber if you want it to be absorbing of energy? And so there was a technical problem that we started to uncover. Then we talked to then the third one was we talked to a manufacturer of geospatial engineering equipment, and they use carbon fiber, which then blocks the radio signal for the GPS receivers. And so they're getting a blind spot in their data when they're going and doing surveying. And so it was like, well, okay, apparently, according to this research that my professor did, natural fibers are radio transparent. So what if you had a material that was radio transparent, absorbed energy, that was better for humans to work with and better for the environment? And it was like, okay, those are the things that we have to design to and deliver to. And so that became the brief to which we started building KiwiFibre.
And so you started during university then, while you were still kind of doing your degree, building that first product that you wanted to build? Or was it afterwards?
Yeah, so this was end of 2021, start of 2022. So we graduated in November 2022, and that's when we raised our first capital. And we're around the time that we met Mark and NZVC. And so we basically, after that point that we figured out what the industry wanted and that there were potential customers in here, it was like, cool, let's get some stuff to them so that we can, start to see this dream come to life. And so we stopped going to lectures. We kind of just watched those online because they were recorded, and the ROI of actually turning up to lectures wasn't great. We luckily by that point I'd finished all of my industrial design papers, and so I was just doing commerce papers, so I could just do that like quite easily. I did most of my management papers on KiwiFibre, so it was like two birds with one stone. So yeah, we just kept developing it in the background and kept joining the dots. And by November 2022, basically October 2022, we had a system in mind where we had an idea that we could build a new industry. No idea how we were going to do it, how we were going to scale it. We just knew that it might be possible. We knew that we could replace fiberglass with Harakeke fiber because we'd hired some machines to prove that in a manufacturing setting. And we had all of these customer conversations that we had, learning about the problem and what needed to be built. So it's like, we might have a supply chain. We've got a bit of an idea about manufacturing being feasible, and we've got a bit of an idea about how the market could size up for this. So we put it all together, and we actually had the framework of a business, and we just were like, well, next step is to just spend heaps of time on this and just keep identifying the dots and starting to join the dots. And so for the last couple of years, that's what we've been doing, just joining all these dots, and now things are starting to work. But quick story as well around how we proved that. So before we raised capital, we needed to prove a few things. And one of the major things was that you could substitute fiberglass with Harakeke. And so we found a manufacturer in Christchurch that was keen to help us prove that by unplugging their fiberglass and plugging in the Harakeke. But it was going to cost us $5,000 to do the trial. We didn't have $5,000. We also didn't have the fiber. We found the fiber, and we found a machine that could process the fiber into a usable state for the manufacturer. But then again, they were going to charge us $5,000 again. So we needed 10 grand. And it was like, where on earth are we going to get 10 grand from? Like, my parents aren't going to give me 10 grand. I don't have 10 grand. We ended up seeing on Facebook a competition from an energy drink company. And it was like, you make a little video, a little skit about how you're going to change the world. 2-minute video, make it funny. We entered that, and we won 10 grand from that. And so we were ads. They used us as ads for selling their energy drink for the next like 2 months. And that was just kind of hilarious. But that was the first money to
you have to share that video with us.
We'll cut it into the podcast.
Yeah, I'll send a bit of it across. It's a YouTube link. But yeah, so that was the first like 10 grams to like prove the first thing. And once we proved that first thing, then everything started snowballing after that.
What was it like raising money I guess you were 22 by that point, right? Or 23. Did you
22.
Did you ever get feedback on like, oh, you don't have any experience? What is it like raising money at such an early age?
Yeah. Around that time when we were starting to identify the fact that, there was a seriously cool opportunity here, there were a couple of founders around the university who were using the free office space at the university. One of those was Luke Campbell from VXT, who you guys are invested in as well. And he made a couple of introductions to a couple of angel investors and Mahesh from Phase One Ventures, and you guys eventually as well. But that was really important because it basically allowed us to dip a toe in the world of venture capital and learning to see what all of these other kind of investment vehicles are like, and learning what angel investing is, how it works, what do they expect, what private equity is, and all of the same things there. So we just started talking to all these people and all these investors, just trying to learn what it was all about, because we had no idea. Like, I didn't even know what an angel investor was. I thought they just like came down from the sky, gave you money, and disappeared again. It was like, I had no idea, absolutely no idea. But by like the 50th or 60th conversation, it was like, okay, I'm starting to get a bit of momentum here. My investment deck is like getting better and better. It's getting some good feedback. I'm getting into the swing of, this capital raising thing. And there was a lot of comments that were sort of like, oh, you're too young, you don't know what you're doing. And I'm like, yeah, but that ignorance is kind of like key in doing a lot of this, because otherwise you try and scale things too quickly because you want to just think about the future, and think about, what's the point in doing this if it's not scalable? Whereas I don't care. We just like go and do it and figure out the rest later. And we did have a lot of grey hair behind us as well, which is a term that one of those early investor conversations gave me. It was like, sure, we're a couple of young founders, but we do have a lot of experienced people behind us that are helping us make things happen.
Right. Okay. Cool. And then did you ever think like, oh, I should get a real job somewhere? Like, was there ever a moment where you were kind of doubting what you're doing after university?
I'd had a couple of real jobs like in the holidays of university and that sort of thing, and it was just kind of average. Like, the companies I worked for were either incredibly boring desk jobs where your boss thanks you by buying you Domino's pizza once a year, or I was just sitting in traffic just trying to get to work every day. It was just really unfulfilling work. And so I was like, I just didn't want a proper job. It was like, nah, this isn't for me. I just love the autonomy.
If we go back to the product itself, right? So I'm just curious, what does it kind of mean to make one of these like carbon fiber alternative materials? What goes into it, right? So I understand you have a plant. You explained this to me when we first met, but I'd love for you to explain it again. Like, you go from a plant to something very, very hard. How does that happen? What are the steps required to do that?
Yeah, it's a good question, because it's a plant in the ground and a race car or a snowboard sitting there are two very just different things, right? So I guess you can preface it by saying, like, there's a bit of an overview as well. Like, so KiwiFibre is a natural fiber composite material, and it directly replaces carbon fiber and fiberglass, and it solves technical and environmental challenges of global industries. And that's thanks to its properties like radio transparency, vibration damping, etc. The way that composites are made is you start with a fabric, and that fabric then is like, a fabric is flimsy and it's flexible, which means that it can fully drape itself around a 3D shape. which means that the benefit in composites compared to other materials is that you can achieve crazy shapes, like the shapes that you see or the geometries that you see in cars or in boats or in bicycles, for instance. They're all these wacky, like crazy geometric shapes. You can't economically or technically make those from traditional materials like woods or plastics, or even if you can, you don't get the strength requirements. And so there's a specific use case in which you use composites instead of another material. And it's basically for strength or lightweightness, or because it's a crazy shape. Like thinking things like wind turbines, for instance, those need to be a very specific engineered flex, and they need to be a very specific weight and all this kind of thing. There's all these requirements, and you can achieve those through composites. So the way that you make let's just say a race car front bumper from a composite. So normally you take the mold, which is like a negative imprint of the actual bumper. And then that mold, you lay up all of the fabric that's cut to shape. So you just basically place bits of fabric inside that mold. And then you place a vacuum bag over the top of it, and you draw resin, which is like a glue, under vacuum using an air compressor, and you basically draw that resin through all of the fabric that's sitting inside that mold, and it fully impregnates all of the fibers. And then you basically place that system into an autoclave, which is a big oven, and then it sets and it cures the glue or the resin, and then you end up with a rigid fabric, which is the composite part. And that's the process which is followed for basically every industry in the world that is a tangible thing. So that's things like boats, so marine, automotive, infrastructure, mobility, transportation, sports equipment, aviation, aerospace. All of those industries use composites in that exact same way. And KiwiFibre can be used the exact same way. You don't need to replace processes. You don't need to redesign the product to use a new material to an extent. It's basically just a drag and drop replacement. So instead of using a fabric that's made from oil or a fabric that's made from incinerated sand, which is what carbon fiber and fiberglass are, you just lay a fabric made from harakeke in there. And so what we've developed is the way to make that fabric from the plant.
So why do people use, fabric developed from oil or sand, incinerated sand, like you said? Why was that the first go-to versus using a plant to begin with?
Well, funny you say that, because natural fiber composites aren't a new thing at all. So a natural fiber, the earliest example of a natural fiber composite is probably like a mud hut, like when we were like thousands of years ago, right? You had a mud hut, and then humans or cavemen realized that if you put like grass or fiber or straw in the muddy mixture to make your mud hut, it would be stronger. And so when your caveman friend came home drunk, he wouldn't, bowl and break your house down. Then in the early 1900s, Henry Ford made
so
a
in
hemp
that
car.
example, in the mud cut example, the mud is actually the equivalent of the resin.
Exactly. So the fiber gives the resin strength, and the resin gives the fiber strength, and the properties of the material come from the fiber that's kept in shape from the resin. So that's how the two interrelate and how they work, which is important to understand, because that is how composites work. And composites are definitely, with everything needing to be lighter and stronger and higher performing nowadays, especially when things are becoming powered by batteries and electric motors, which are much heavier, or things that have greater connectivity through the Internet of Things. There's requirements there that are only met with composite materials. So there's definitely an advantage there.
The fiber and the resin, they bring two different properties. You're saying the resin brings the hardness, the fiber brings the, like, what would you call that? The holding it together?
Yeah, so the majority of the properties come from the fiber itself, because there's things like the hollowness and the actual, tensile strength and compression of the actual fibers, and they're held together in their orientation by the resin.
Got it. Okay.
It's called the matrix. Yeah.
Got it. And you were saying Henry Ford then did something.
Yes. So a few years after the cavemen, then because that's a good example of explaining it actually. Then Henry Ford in the early 90s built a hemp car. It was hemp fabric and it was infused in some kind of resin at the time. And he built a car out of it.
Hmm.
And that was shut down around, in the early to mid 20th century because of the perception of natural fibers, particularly of hemp and its association with cannabis. It was shut down because, people and regulations and industries did not want the association with drugs. And so that is one of the things that actually prevented natural fiber composites from taking off in the early 1900s. And a similar thing happened then later in the century when basically big oil stopped development of natural fiber composite things because their oil products then went into carbon fiber, which then went into making these same materials. So yes, carbon fiber and synthetic petroleum-based materials, they've got their strengths and they should be used in certain instances, but there's so many other applications out in the world that do not need that raw strength and can certainly be replaced very easily by natural fiber composites. But there's been a few phenomenon through the last century that has prevented that from taking place.
Wow. So you're saying it's actually a much better material for a lot of use cases, but the association with cannabis and then big oil both kind of like shut it down, basically
Yeah,
prevented people from developing products using
exactly.
natural hemp.
Exactly. People could definitely
And
take that as a bit of a conspiracy theorist view on it, but who really knows? Maybe it was just crap.
right. Interesting. So are people now, so then what was the story kind of where does it lead us now? So are people
Mm,
now trying to use more of these types of materials? What kind of use case are they better for? And I guess where do you come in that whole
mm.
thing?
Yep. Yeah. So leading on from there, I guess over the last since Henry Ford worked on that car and since these kind of things have tried to start and failed for various reasons, since all of then, science and technology has caught up, and now humanity is been able to develop um, develop equipment, develop materials that is far superior to what was possible before. So basically, science has allowed us to get natural fibers to a point where they're actually very usable and can start to push the limits on what we know them as and get them to start competing with man-made materials. The second thing is timing in the market. So and that ties into the sustainability piece, which is it's not the decision-making factor for the vast majority of companies, but it is nice to have, and you do need to keep everybody happy so if you're selling to a big company, you need to keep everybody happy. You need the sustainability and the life cycle analysis people happy, just as you need the accountants happy in order for them to purchase it. And so now that there are regulations going on around the world for, looking at CO2 of imports and looking at the actual end of life considerations of products, the sustainability is huge, but it wasn't before. So that's why it's working now. The third thing is, branding is actually quite huge. Like consumers are becoming more educated, and so they want to know where the material comes from. They want to know where the materials that go into their products come from, and you start to see that a lot more in the fashion industry now. And the only reason it's not in other industries is because that story hasn't been available. But there's a much greater connection now between consumers and their products, especially from a branding and story perspective. And then I guess the fourth one is science has come a long way, and so now you can actually use a material for the benefits that it presents. And as long as you're very clear about what a material is good at and what it's not good at, then you can manage expectations and you can actually get the material being used for what it is good at. So we explain it as a replacement for carbon fiber and fiberglass to make it seem like a simple concept, and that's accurate. But when we're talking to a specialist boat builder or a aerospace engineer, it's a material that you use for radio transparency, vibration damping, and non-conductivity. It's not a replacement for carbon fiber. So there's definitely instances where you should be using it, and there's instances where you shouldn't be using it.
And so the first product where you've put KiwiFibre in is a car, right? Is this
Yes.
one?
So yeah, that's the one. So that is an electric rally car using KiwiFibre in the front bumper, the roof, the rear bumper, and some of the interior panels. And that's it's a very fast car that's driven by Hayden Paddon, so a famous New Zealand rally car driver. So it's been a great promotional thing for us. And it kind of ties in the story now, right? Like turn plants into race cars. We've finally got a race car that we're part of. And that helps then with our like first markets as well, with especially in snow sports. Like who doesn't want a pair of skis made from race cars, you know? And it's that whole branding and storytelling piece that is something that natural composites hasn't really had before.
That must have been an incredible moment when you stood in front of that car, right? Because that was always kind of your dream.
Yeah. Yeah, it was pretty cool to see that in person.
I can imagine. And so now you're trying, or you're selling it into kind of, you said snowboarding or like winter sports in general. And we just chatted a little bit before. Your market is mostly in Europe at the moment, correct?
Yeah, that's right.
Why is that? Like, why are Europeans more interested than maybe other manufacturers?
Yeah, it's a good question. So there, like I mentioned earlier, there are so many industries that could use this. And so one of the biggest challenges for us up until now is like, where on earth do we start? There's been interest from just every industry in the world. So we needed to really narrow down on one to focus with. Because there were ideas of like, hey, we could focus on, we could keep the material specification and products simple and lean, and we could sell into every market, or we could, pick 10 and go and do that. But we've realized this year we just need to focus on one kind of product, one industry, one customer. And we've identified that as being the snow sports industry, specifically snowboards. And so our first customer is a German snowboard manufacturer that's a small manufacturer, large enough to be doing proper manufacturing runs in a factory rather than in someone's garage, but small enough so that we can get to know the decision makers, get to understand their consumers, their customers, and really just create as much value for them as possible.
Yeah, Ben, you mentioned that when you went to that conference in Germany, I guess where you met these guys, somebody actually stole the snowboard.
Yeah. So we went to the International Sporting Products Conference in Munich in the end of 2023. Well, I personally didn't go. Will, the co-founder, and Richie, our engineer, they went and met the coolest companies in the world that want to build stuff from KiwiFibre. It was just like every company that you'd want to work with ever was there. And we bought a snowboard along, and it got stolen on the last day. When we were packing up, somebody went and nicked it.
So somebody's out there taking the slopes on the world's first and only so far Harakeke snowboard.
Yep. We've built another snowboard since, but yep, that was the first one. It's the world's most stolen snowboard, that's for sure.
You must have sold it really well. They were like, man, we gotta have this. We're taking this one.
Yeah. Yeah. I like to think it was corporate espionage. Maybe it's one of the big snowboard manufacturers trying to figure out how he made such a good product.
So what makes that snowboard, and I guess other products that you build out of Harakeke, what makes them better than the alternatives? Why would somebody be interested in using it or stealing it for corporate?
Yeah.
What makes
Other than the fact that it's really cool that you turn plants into snowboards, which is something people love, it dampens vibrations, which is really important in a snowboard. You want a certain level of stiffness, but you also want a certain level of springiness, and you get that from material selection. The second thing is the actual lightweightness of it. So you end up with a really light board because of the low density of Harakeke compared to fiberglass and even carbon fiber. So the density of Harakeke is like 1.27 grams per cubic centimeters, whereas carbon fiber is around sort of 1.5 and glass is about 3. Then the impact resistance and durability is much greater with KiwiFibre compared to carbon fiber. And that's, again, because it's less stiff than carbon fiber, it's less brittle, and then it's less likely to crack and less likely to break. So you end up with a more durable product. So that's what all of the theory says about using such material, and that's what the testing data says. But again, the best way to test something is you just got to put it into a snowboard and ride the hell out of it. And that's what the first manufacturer, the first customer will be doing. So they'll be doing a manufacturing run halfway through 2025 using KiwiFibre instead of their fiberglass that they normally use. And then they're going to give it to some of their sponsored athletes, and they're just going to thrash it and give us as much feedback as possible.
Wow. What about other hemp-based products? Is KiwiFibre better than those?
Yeah, so there's a lot of differences between Harakeke and like other natural fibers like hemp and linen, which are still materials and fibers that can be processed into equivalent textiles. But there's a few differences. So Harakeke is much longer fibers than hemp and linen. So with Harakeke, the leaves themselves can get up to about 2 meters long, and the fibers run the entire length. So like one of the reasons which carbon fiber is so strong is because the fibers are infinitely long. So if you can have a natural fiber composite material with really long fibers, that's an incredibly exciting thing. The hollowness as well of Harakeke fibers, they're very hollow, and that's a thing called Lumen factor, and that is advantageous for impact absorption due to the second moment of inertia and the ability for them to absorb sound as well. And that makes them more buoyant theoretically. And then the actual raw plant as well. So with hemp, you plant out fields and fields of hemp plants, and then you wait for it to, so it's all in a monoculture. So the soil itself gets quite, and this is away from the engineering chat, it's more towards like why Harakeke is an amazing thing as a plant. So with hemp, you plant out a whole field, and then you take a diesel powered combine harvester and you go and harvest the whole thing. And then you plant the same thing again, and the soil itself gets a bit tired after a few years, which isn't a good thing. Whereas with Harakeke, you plant on land which is unproductive or is a liability for farmers, and then you can still grow food instead of hemp on the productive land. And I've done a calculation. If you turned all of the non-productive land on every farm in the world into growing Harakeke to make KiwiFibre, we'll be making something like $1 billion a year. Like it's insane. And that is because the way that you harvest Harakeke is you harvest just the outside leaves, which then allows it to grow back really, really fast. And that's actually what the KiwiFibre logo is inspired by. So those outside leaves are what you harvest. They grow back really fast. The yield per leaf is really, really high. So the efficiency is way greater than driving a diesel combine harvester to go and harvest it. Then you get the byproducts as well, which of course hemp has as well. Yeah, it's much better for the environment than hemp and linen. And we're about to back that up. We're doing a life cycle analysis right now.
Wow. So that's the logo there. So Ben, I mean, it sounds like, when you first told me about this, and then you said there's a lot of other folks making hemp-based materials, and they have a global patent on them. But the reason we can do this is Harakeke is not actually a hemp, right? So it's a lily, if I remember correctly, right? So it sounds like it was like a superior material from all the different points of view. And it didn't fall under this like global patent that this other company had. So you guys are like the only ones in the world who can actually grow and make this material. And no one else really has the ability to do that, right?
No, that's right. That's right. We've developed a machine totally custom, totally bespoke that extracts the fiber from the leaf. And that's something that people have been trying to do for a very, very long time in a safe, scalable 21st century way. Because there were machines in the 1800s, but they are incredibly dangerous and very inefficient. So we had to build a 21st century one. So we're the only ones in the world with that machine. We're the only ones in the world that have figured out all of the sub steps. Like you extract the fiber, and that's great, but you still need to turn it into a textile. And that is a really challenging process to go through. And so we've gone through every machine in the world basically to figure out what's compatible with KiwiFibre, what's compatible with Harakeke to make KiwiFibre, and what's not. And that's resulted in us now having an understanding of the full process to turn Harakeke into materials to rival carbon fiber kind of thing.
Wow.
So we're the only ones.
Wow. How did you build that machine? What does the machine do? How does that work? And what was wrong with the previous machines?
The previous machines were those 1800s ones, which are incredibly dangerous and would take people's fingers off. And you adjusted the tolerance by taking two spinning pieces of metal together. And when sparks start to show, that means you got the tolerance right. So that's why they all burnt down back in the day. But then people have tried to build 21st century ones, like modern versions, but they've failed because they didn't know what they were designing to. So they were trying to develop the best fiber quality possible, and they achieved that. And they built machines which have severely limited scale and very, very hard to scale up. And so they can do sort of like maybe 1 or 2 kilograms of very high quality fiber a week, whereas we can produce what they produce in a week in about 30 seconds on our machine. So we were able to get this to a point of sensible scalability because we knew exactly what level of fiber quality we were after. And that was all driven by the customers telling us what it needed to be. They said it needed to be this kind of thickness, this kind of weight. And we were like, okay, well, that's actually not too difficult of a thing to design to. So we knew what to design to with all of our equipment that we developed because customers told us what. Because if you went and did it how academics had done it for Harakeke projects in the past, and there's been a few like Crown Research Institutes and things that have done this like in the 90s and the early 2000s. But they didn't go anywhere because they didn't have customers telling them what to build, whereas we did.
Right. So, and that's a good point. I actually didn't ask about that. How do you go from like the leaf on the tree? Because you told us you take, fiber and you lay it into a 3D mold, you pour the resin, you heat it, that's how you get the final product. But how do you go from the plant to the fiber? I guess that's what the machine does, right? What actually happens there?
So that's composite manufacturing process with the fabric into the mold. That's what our customer does. So we've actually got a really simple business. We just sell fabric. That's it. But we got to make that fabric, and we got to make it to the right spec, and we got to sell it in the right way. We got to build the right brand around it, and we have to get it the right scale and the right price point and the right contracts and all of that. And so that's what we're focusing on. So the process to get from the leaf that's growing on the bush, all happy, to a fabric stage, that's relatively sensitive IP, but the essence of it is that you feed the leaf through our proprietary machine, and that extracts raw fiber that kind of looks like a ponytail. It's kind of like hair that's kind of like this long. That is then basically bundled up into a big bundle, and then that goes through a series of other machines which basically beat it and comb it and all this kind of thing. And that's processes that are relatively similar, but also completely different to other natural fiber industries. And then you end up with a yarn, and then you can weave that yarn into the right specification of fabric. And that at that right specification of fabric, that's when we can sell it to a customer who then goes and turns it into a front bumper kind of thing. But there's a series of steps in there, and the magic has been in adjusting form factors of fiber so that it can go into different industries so that we don't have to reinvent the wheel.
And I mean, I've seen a Harakeke plant, it has fibers all along the leaves, right? So you guys, basically what you're doing is you're kind of just extracting those fibers. Is there anything else in the leaf? Like what are those fibers held together by? So whatever that material is, you're sort of like removing that and then getting that yarn to then be able to like sell on as a fabric, right?
Yeah. So it's got the fibers going all the way through. So like a cross section of the leaf, you can see like all these little dots, and those are all the fibers. And so they're basically encased in like this green, meaty kind of material. And so we end up with a big pile of green matter, which is actually incredibly rich in all of these other extracts and all these other juices and all this kind of thing. And absolutely, it's beautiful material. But at the moment, there's two things that we've done with all of that green stuff. We've fed it to cows, and cows really love it. And we've turned it into beer. Those are the two things we've done with it so far. We've turned it into beer. It's a Harakeke Pale Ale.
Is that some tired engineers in the office who are like, man, we need a break?
Pretty much. We'll brew some
How do you
beer.
turn it into beer? You use that to ferment? You use that to ferment some.
Pretty much, yeah.
That's how you do it. Ah.
Yeah, we put it in with the malt and the mash process, and then it like puts it through, and you end up with a bit of a bitter taste.
Oh, you didn't tell us about that. It's not good.
It's not amazing.
Oh, okay.
Well,
need a bit of R&D.
Just maybe if you sell to German clients, you should probably bring them some. They probably enjoy that. They're very much.
Yes, I think so.
Cool.
Yeah, and I mean, it's one thing I kind of like as you were talking. I mean, it sounds like, like when Elon Musk was building Teslas, and he's like, okay, the bottleneck is like batteries. We're going to build kind of the super factory to build batteries. It sounds like that's what you're doing, right? You're like, we have this thing, Harakeke, but actually it turns out we need to build a machine to extract it. We can't just like, so you're kind of building every single part of this, but you're like, it sounds very ambitious what you're doing.
Yeah, I mean, it's quite a good analogy there as well, because like it's very easy to build a car. There's so many people that have built cars, right? So in the Tesla analogy, there's if you want to build the best car, you're not going to. And if you want to build like Teslas aren't actually the best car. They're pretty, the build quality on them is pretty average. But what's incredible is the actual battery technology and the infrastructure that is going alongside that. And so the car is like what Ferrari is to Tesla is like the Ferrari is the carbon fiber. Tesla is like the KiwiFibre, and the battery technology is the innovation that we've driven within Harakeke Fiber itself, because that is what then drives the KiwiFibre material and makes the KiwiFibre material so good in the same way as Tesla's kind of cool, So that's kind of a good analogy, I'll say.
So where do you go from here? What's the big vision? I mean, with Elon Musk, his vision is to obviously bring kind of electrification a step closer, get every car manufacturer to switch and be an electric car manufacturer. And I feel like, over the last 10, 15 years, he's done that, right? What's your vision for the world and what you're building?
Yeah, the vision of KiwiFibre and of myself and Will as founders is for this world to be one where the resources that are required to build things are not extracting from the world, and that they aren't extracting from people's health and from the environment, and rather that they can actually benefit the environment. And so the vision is that everything, instead of being made from petrochemicals, can be made from plants and without compromising performance. So yeah, everything in the world to be made of KiwiFibre is like the dream. I'll know that we've made that once we make a Formula One car from Harakeke. Then it'll be like, right, this is real. But before that, we're still working.
That's cool. That's cool. And what's your feeling about working and being based in New Zealand? How do you, and would you say it's an advantage? Obviously, you wouldn't have had the access to the rich history, the Harakeke itself. But beyond that, I mean, yeah, maybe for folks who are looking to build companies out of New Zealand or be based in New Zealand while they're building a company, what would you say have been the pros and the cons? And do you have any unfair advantages being based here?
Yeah, looking at it skeptically, you need to have a bloody good reason for building something out of New Zealand. There are I'd never actually traveled. I'd never actually left New Zealand until 2023 when we went to Europe for a trade show and met a few customers and investors and things. I'd never even traveled, so I was so ignorant to the fact that New Zealand was so far away and logistically really difficult to do business with. But that was probably a blessing in disguise, because if I knew how far away New Zealand was, and I knew that there were opportunities in, I don't know, the States and San Francisco and startups instead of in Christchurch, I might have done something different, who knows? But like there is a handful of things that New Zealand does really well. And if you can really benefit those and stretch those into something entirely new, I think that's something really exciting to build a business out of. So like one of those things that New Zealand is really good at is education. The education system, like it produces very good engineers. It produces number 8 wire thinking. It produces out of the box thinking, which can be turned into a really good thing within startup land. New Zealand has, it's got, I mean, the tourism and the landscape is a really cool thing, and that attracts people with money. It attracts people who have been successful elsewhere to come and be here. And so with that comes a lot of tech expertise and a lot of investors and a lot of really great operators. And so if you can engage with those types of people to help build something cool out of New Zealand, then I think that's really special as well. But what's special for us is the fact that there is this weird plant that grows in New Zealand and nowhere else that is so much better than every other plant in the world. And once you start to tie in the rich history and the cultural history around it, then you can build a product which can really fly, almost literally. In fact, it can fly, like we've sent it to space before. But you can, there's things New Zealand's good at, and if you can extract those and build something from that, then you're onto something.
Wow. Yeah, that's really something. I mean, I think your point about, being scrappy and the number 8 wire mentality. I mean, I think without that, you wouldn't have gone on this kind of exploration and found this deep history of this material that only exists here. So I think that also speaks to your ability to leverage that and harness that mentality. And I hope that more folks can leverage that here and discover what else there's special that they can bring to a global audience.
Oh, exactly. And there's
really
a lot
cool.
special, like the aerospace sector and the growth that's seen in the last decade or so with all these space companies popping up in New Zealand. That actually is a bit of homage to New Zealand's rich aviation history in the early 1900s with New Zealand being, really ahead of its time in the early 1900s, late 1800s with, discovering flight. Things like that. There's a lot of synergies between old and new, just like, KiwiFibre with the Harakeke industry now going back to the first industry. And so there's lots of these innovations that are happening now that are like mirror imaging things that have happened in New Zealand's history and things that New Zealand is uniquely good at. So yeah, it's quite cool.
Very cool. No, we're excited. Great. Would love to wrap it up. If I can just ask you a few more questions with a very quick answer, if that's okay.
Yep, let's get them done.
Awesome. So I'm just curious, you said you haven't traveled much before doing this. Is there any country in the world that you'd love to visit?
I'd love to go to Morocco. I don't know why.
Okay.
It just looks insane. I'd love to do a road trip from Europe across into North Africa. That'd be cool.
That sounds pretty awesome. What are you going to do for your 25th birthday?
I'm going to do an amazing race with some friends across Christchurch. We're going to just have a couple of drinks and go across the city and tick off all these tasks and try to get as many points as we can. Amazing race.
Nice. What's the best piece of advice you've ever received?
Do things that don't scale. Just do things scrappy. Don't worry about scaling them. Just have fun with the process and learn through being scrappy. So yeah, I'd say in relation to business, just do things that don't scale, and in relation to personal growth, and which then feeds into business. Probably advice that Mahesh gave me, which was get on a plane, get your passport, go see what the world's about, and bring things back to New Zealand.
Awesome. That's great. Well, Ben, thank you so much. We hope that KiwiFibre is going to scale and that you're going to do great. And yeah, we're looking forward to seeing what you're going to achieve. Cool. Thanks so much.
That was a good chat. It was really fun. Bye. See you guys.
Thank you for tuning in to TechMates. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with friends. We'll be back soon with more stories of Kiwi and Aussie founders reshaping the future and disrupting down under. Until next time, keep dreaming big and daring to disrupt.